Hello, everybody, and welcome back to Wise Lies. Hopefully, by now, I've convinced you that computer science is everywhere, and that should hopefully convince you that computer science is really important in practice as well, regardless of whether you actually want to do computer science, like I am, or whether you just use a computer for as a tool for whatever other research you're interested in, or whatever else your job might be. Important in practice to know at least a little bit about computer science and all of the things that we talked about. For example, the internet. How does the internet work? How does all of this fit together? Really important to know in practice. Even if you're maybe not working with a computer, studying computer science can be rewarding and interesting because theoretical computer science, for example, is not really concerned with computers, but more with how they work in theory. So it's really more math than what we would think of as computer science in terms of programming, developing algorithms, developing methods to solve difficult problems, for example, in artificial intelligence and things like that. Computer science can also really help you to formalize how you're thinking about solving problems, because that's what we need to do to teach a computer how to solve a problem that we might intuitively solve as a human. For example, I'm moving my hand here and I'm not even thinking about it. I have done this so often. I have learned this from a very early age that I can just make my hand do what I want it to do without even really being aware of what's happening. If I want to teach the same thing to a robot, I need to be very specific about what needs to happen to make a movement like this, for example, happen. As it turns out, this is really difficult in practice because a lot of different things need to come together and a lot of different operations need to happen. Studying computer science can help us think about this in a more principled fashion and really think about what are all the components that come together to make my hand move, for example, or to solve a particular problem that I'm interested in solving in practice. For example, the real world applications that we briefly talked about in the previous video. So even if my primary interest is not in computer science, thinking like a computer scientist can be good and interesting because it allows me to tackle problems in a very principled fashion. Not necessarily just problems in computer science, but problems in other disciplines, problems in biology, in physics, in other areas of engineering, and all kinds of different things. So, computer science, useful and important, not only really if you want to work with computers, but also as a way to get to a more principled way of thinking, and in particular, a more principled way of solving problems. Because solving problems is really at the heart of what a lot of computer scientists do in practice. When I do research in artificial intelligence, I think about difficult problems and better ways of solving them. Or maybe nobody has actually solved this particular problem before, and this is then even harder because I need to come up with a way of solving this problem that nobody has figured out before how to solve. A principled way of thinking about this, taking a big problem and breaking it down into individual smaller subproblems is really at the heart of computer science and is really at the heart of the programming that we're going to have a look at later on. You might have a big task that you want to solve and you don't even really know where to start. Computer science can help you with that because it helps you to think strategically. How do I take this problem and break it down into smaller subproblems? Okay, this first small subproblem, I actually already know how to solve that because I have seen this in a different context, maybe in a slightly different form, but really I know how to tackle this. Great, now I'm well on my way to solving the big problem. I've tackled the first subproblem. Let's have a look at the second subproblem. Maybe this one is too difficult still, so I can break it down further into even smaller parts until eventually, hopefully, the individual parts become so easy that I can solve them in a very straightforward fashion. I don't even really need to think about this. Yes, this is obviously the solution to that. Then, of course, the difficulty is taking all of these pieces, all of these individual subproblems that we have solved, and putting them back together to get the entire whole that we're really interested in. Again, a core part of computer science, and we will be looking at that and practicing that in the programming part as well. So, computer science all around us, very important in practice. You want to have at least a basic understanding of how computers work, how networks work. The internet is essentially one big computer. So, computer science is really a very wide domain, really very wide discipline that has applications all over the place, both in everyday life, but also in research and in any other job that you might want to do. Computer science, very important in practice. I hope that I don't have to convince you of that. That's why you're here, right? So let's go and learn more about computer science and, in particular, do some programming exercises.